Good afternoon. Welcome again to the 2023 Northeast Bridge Preservation Partnership. My name is Scott Snyder. I'm a bridge maintenance quality assurance engineer for PennDOT out of Central Office, Harrisburg, PA, and it's my pleasure to be here to moderate this coding section. With that, let me see here. We have 3 presentations here, then a panel session. We have Mr. Levi Byers from North Hampshire DOT with the next beam Superstructure. He's up and running. We'll get him up here in a second. Portland paint failure phenomena with Ben Foster out of Maine DOT. And the third presentation today is going to be trials and tribulations with bridge painting with Jonathan Moore out of NHDOT. Without further ado, I will enter Mr. Levi Byers from New Hampshire, DOT next beam Superstructure replacement. Thank you.
All right, very good. My presentation isn't on coatings, but you get a little reprieve from that. Well, there'll be coatings after that. But anyway, my name is Levi Byers. I'm the senior engineer in bridge maintenance at New Hampshire DOT. You know, the last session there was kind of a couple of really large-scale, big-picture projects. This particular presentation is a lot smaller scale. That's the superstructure replacement of a 53-foot span, single-span bridge using next beams. But it was a project that we did in-house using agency forces. The entire project was done from design, all aspects of design, you know, material procurement and construction in-house by our state forces. I assume most people here are probably familiar with next beams, but if you aren't, it's a Northeast extreme beam, and it's not proprietary, but it's a regional standard that was developed by agencies, consultants, and fabricators. PCI certified fabricators are able to make them. Just really briefly, just a brief little overview of our bureau in New Hampshire. We have about 100 full-time staff, 25 part-time. Most of them are lift bridge operators and workers. We have 13 crews total, 11 construction crews, another construction and lift bridge maintenance and operation crew, and then we have our stockyard crew. We're similar, a little bit larger than NHDOT, but we have just under 2,200 bridges. We consider any structure over 10 feet a bridge in New Hampshire, and we operate 4 movable bridges. You know, our crews are about 6 to 7 people. Right now we're going through really significant staffing issues, both the crew level and the engineering level across New Hampshire DOT. But the job must go on, so we just have to be innovative in what we're doing and overcome some of those obstacles. And so, as I said, this presentation is going to be more focused on, you know, doing these, a project that would probably typically be on the capital side, but one that we did in-house. We like to do these every few years for experience for our crews and for our office staff. And it's just one less bridge that has to go out to bid. You know, why hire a contractor when you can do it yourself? So this particular project, it had fairly easy geometry. There was easy permitting, no major right-of-way or utility changes. So the existing bridge was constructed in 1934. It was a concrete T-beam bridge. It was widened in 1984 by our bridge maintenance forces. They widened it with salvage steel girders, W36 by 150 girders. And in 2021, we committed to moving forward to replace the superstructure, and in 2022, the rating at that point was a 747. It had been 8 years in poor condition because of the superstructure. So we started with preliminary design. We knew early on that we wanted to replace the superstructure with next beams. In New Hampshire, I think at that point we had, as a department, had done, I think, 4 bridges with next beams, so we thought we could use their experience on the capital side, and you know, use speaking with our construction folks and bridge design folks, and apply their lessons learned to do a project ourselves. If you're not familiar with the PCI Northeast design guidelines, I highly recommend you look at them if you're, whether it's a next beam or anything really that is precast and pre-stressed. They have great guidelines that help with preliminary design and just the design in general. There's a lot of lessons learned that are even incorporated into those guidelines. They're updated on a frequent basis. So I think this morning we heard about the CMGC. You're probably all familiar with, you know, design, bid, build, or design, build. We usually joke in our bureau that we often do things, you know, no bid or with a low bid because no one wants to do the job. And then we also jokingly say we usually go the build design route. That's how maintenance usually works, because you get out there and you don't always know what you're going to get into. But obviously for this project we couldn't do that. We had to, you know, kind of follow a proper design process and preliminary design survey. But here you can just see some project timelines. We really started things in November of 21, and we have a survey section where we usually farm out any survey needs that we had, but we didn't want to wait for them, so we decided to just do the survey ourselves, and we borrowed a GPS rover from our construction folks, and we surveyed the whole project. The software we used was Field Genius by Microsurvey. If you're familiar with GPS rovers, this particular one, there's no base station. It's all just one mobile unit, but you have to have good cell service. We barely had enough to do it, but we were able to do it. You know, one thing that was just really critical, as with any construction project, is you know, lead times with materials, and that's usually not something that you deal with as much on the maintenance side, or you just have things in stock. But with this particular project, it was kind of coming out of COVID, supply chain issues. There was serious lead times for guardrail and bridge rail, you know, 6+ months from shop drawing approvals. So actually the first thing that we even had final designed on this bridge was the bridge rail, because of the lead time. We had it done before we even had thought about doing anything with the deck or the next beams. We ended up going with, there's 3 types of next beams. There's D, E, and F. D is the beam with a full cast deck that on top of the beam. The next E beam is basically a partial depth deck that you overlay. And the F is basically just the beams with a top flange that acts like a deck form, that you do a full depth overlay, cast in place concrete overlay over. We really wanted to try out the next D beam just to save time, but it just really wasn't feasible, because for this length of bridge, you were looking at a 60,000 pound difference per beam just in weight. So getting that size, we were real limited with space with what size cranes we could get in there. So that was a major factor. Also, most of the closure pours are typically designed with UHPC. We're really interested in it, and there's been a few jobs in New Hampshire with it, but it's not, in our experience, as readily available as it is in other states. And we're not experienced on the maintenance side of things using it, since our crews were going to be, you know, doing the project. That being said, I know at a recent PCI workshop, they did mention that they're coming out with more options and details with shrinkage compensated concrete, more conventional mixes that can be used with closure pours depending on your splice connections. We ended up going with a 8 KSI concrete, self-consolidating concrete that the beams were cast with. The manufacturer, you can go up to 10, but they really recommend against it. And I know right now JP Carrera out of Middlebury, Vermont did the precasting for us. And I know right now they're having issues because of the batch of fly ash that's readily available. They're having trouble getting strengths. The beams this bridge was 4 9-foot wide next beams with a center closure pour because of phasing. We overlaid it with a 4,000 PSI conventional concrete deck. We did use 100 KSI steel MMFX. That's kind of a standard practice that we've been doing in bridge maintenance when we replace decks. 8.5 inch thick with a 1 inch exposed concrete wearing course that's incorporated into the deck. The bridge had elastomeric bearings with internally tapered sole plates to accommodate the road profile, and we decided to go with a semi-integral abutment with no bridge joints. One thing to mention is if you are doing a project with next beams, at least the precaster we were working with, JP Carrera, they have a 250-foot casting bed, so they were actually able to cast all these in one placement. They said they were able to fit us in. They had a very large project going in New York State, but they were able to fit us in between that project. Typical construction phasing, as you can see, on this road it was US 202. It's over the Isinglass River, and there's about 6,500 average cars per day. We did the project using temporary signals, alternating one-way traffic. And so once we got out there, we were able to set up staging. One thing that was convenient, usually I'm used to complaining about wetland permitting. It can be really difficult in New Hampshire to get wetland permits, but in this particular job, we had no permanent impacts. It is a protected river that we were working over, but the only thing that we had in the river was staging, one row of staging. So we were able to just meet with a local river advisory and get their approval, essentially, to get our wetland permit. We built some staging out of glulam beams that we have in inventory to do some of our projects. Because of the difference in, the middle beams are essentially concrete. They're the concrete bulb T-beams, and the outside beams were steel beams. There wasn't a good way to really, do conventional shielding or staging for demolition, so we ended up installing this entire platform under the bridge. Of course, someone left us some nice gifts early on, over a foot of pavement on the deck to remove and lots of ledge buried behind the back wall. Part of me thinks it was probably our maintenance crews back in the 80s leaving some nice gifts for us in the future. We did as I said, we did all the work ourselves. However, of course, there's certain things that we farm out. The saw cutting, we hired saw cutters. You typically, a subcontractor, we call them rentals because we're renting the saw cutting equipment with an operator. So we had the saw cutters come in and help us with the bridge demo. I've been on some larger scale bridge projects, but one thing I had never seen anyone use before, I don't know if it's as common on bridge work, but they kind of had the gambit of saw cutting equipment. Your typical, walk behind, ride on saw cutter, but also they had electric concrete chainsaws and cut-off saws that you could fully plunge to do. They did some cuts into the existing back wall and concrete diaphragms. was really useful. We did the rest of the removal ourselves, kind of in conjunction with them, and I was doing the calculations to make sure, what size slabs that we could pick off at a time and what equipment we had, that our crews had. Of course, things that they might work on paper, but we bit off a little more than we could chew, as you can see in that left photo. And we started, we did some smaller size slabs after that. So sometimes things work on paper, but they don't always work in the field. Saw cutting and slabs on the concrete beams was a little, also something I know, at least for me personally, I wasn't used to doing. It was the first time. So there was a very fine or small margin of error, between saw cutting through the deck, making sure you're cutting through the stirrup that's tying the beam into the deck, but also leaving enough, concrete there so that the whole piece doesn't just fall down onto our staging and probably into the river. So there's about an inch or less margin of error where we had to cut, so we had to do a really good job laying out. After that, we removed the girders. To do this, we had to do a full road closure. For this job, we were able to accommodate traffic the whole time except for girder demolition and girder erection each phase. So we had 4 full road closures, 4 days total throughout the job. We had 250-ton cranes come in to pick the concrete beams. The first phase, we just had one, and we were really limited on space, so you had, cranes either side totally blocking everything in. So they picked the concrete beam off, set it on the existing bridge that was still in place, and we busted it into thirds so we could, it would be more manageable to get off site. The steel beam was a lot easier to remove. The existing concrete beam was about 50,000 pounds. You can see it there, one of the pieces getting loaded into one of our dump trucks. And now we can start rebuilding the new bridge. Here, just a couple pictures rebuilding the top of the abutments and building our bridge seats. And just one kind of thing to, I referenced that we were really short-handed with our crews. For most of this project, we really only had 4 or 5 people on site building the new bridge. During, times where we really needed help, like deck forming and rebar installation, we did bring in another crew to help. And of course, during the demolition, we brought in some subcontractor help, but for the most part, we did this job with 4 to 5 people. The bars sticking out, if you're wondering, are just pins for the fixed end of the bridge that get cast in the back wall. The other side's the other end. Here's the phase 1 next beam erection. We had to close the road again, bring the cranes back in. These type F beams were 70,000 pounds each, and it was kind of a game of not musical chairs, but a lot of equipment jockeying just to kind of get the beams in there. Partial mobilizations of the crane, sucking outriggers in, and moving the tractor trailer and the beam around to set both of the beams for this phase. So there was a lot of planning involved. Utility, we had to get the lines covered because of utilities being close to the bridge. And then after that, of course, the deck construction. As I mentioned, we use MMFX rebar for the entire deck for both mats and the back walls. Here, I just wanted to mention 2 of our kind of exemplary employees. The 2 employees right there have over 65 years of bridge maintenance experience between the 2 of them combined. So we had some really good people on this project. and I'll get to that a little later at the end. Kind of wrapping up rebar installation there on the left, and then doing a dry run with our Razorback screed. And then it came to deck placement day. The deck forming in total, once the beams were erected for this 50-foot span bridge, took about 1.5 to 2 weeks, and that included, overhang construction, rebar installation, back wall forming, curb forming, abutment forming, pretty much everything. And when we cast the deck, we were able to cast it monolithically, which included not just the deck, but the back walls and the curb. So it's all one big piece. We were able to do that for the second phase as well. Of course, just kind of wrapping up the first phase, paving, guardrail. We're very DIY with our bridge maintenance crews, but if we were to, we can install bridge rail and guardrail ourselves, and for this job, it probably would have taken us 2 to 3 days at least. So we're just gonna hire that out and have the pros come in and show us how to do guardrail. And they came in and did it in 1 day, which we were very happy with. I'm not gonna, it's very rinse and repeat here for the second phase, so I'm not gonna go through everything, but just a couple things that were different for the sake of time. For girder demolition on phase 2, we had 2 of the beams to remove. We basically did it with the same method outside of, instead of busting up the beam with a hoe ram or rivet busters, we had the saw cutters come back and saw cut the beam, because it took most of the day just to bust that one beam up during phase 1. So we had the saw cutters come in, and they installed a track saw on the beam once it was removed and set down, and it worked fairly well. It did go quicker. Kind of had its own trials with it, though. One thing that's a pretty common construction bridge phasing issue that shows up in most projects, but in particular with next beams or pre-stressed beams, is differences in deflections creeping between phases because of the continued stresses being incorporated into the beams. That's something that on our capital projects they've seen, especially on bridges with larger skews. Luckily here we had 0 to minimal. There was really almost a 0 degree skew. We did have a little bit of additional deflection on the phase 2 beams because they were installed 2 months later, but it was minimal enough that it wasn't an issue. We had a plan to preload the deck if it was an issue. It can also cause issues getting your mechanical connectors in. Once we got to the deck placement for phase 2, it was later in the year, as the first week of October, and in New Hampshire, it's kind of when it starts turning to winter. It's hit or miss. One day it feels still like summer or early fall. The next day it could be, freezing. So we preheated underneath the beams overnight, but then we kind of had good temperatures after the deck placement, so we didn't have to heat long term, but we just did cover the deck with insulated blankets for 7 days. So in summary, our project from somewhat of inception, I would call it, was the beginning of November of 21. And as you can see there, you can see the dates. Construction started in April of 22. We finished mid-October of 22. And really from inception of preliminary design to construction finish was just about a year. So it's one thing why we like to do some of these larger scale for maintenance projects. We can do them nimbly. It would have taken a lot longer on our capital side, more coordination. working with a contractor and plan preparation. We don't do great in-house and bridge maintenance with a PE cost, but we do a good job tracking our construction costs. We did the project for $630,000. Using our estimate methods, our 2020 data, the project per our estimate would have cost $1.3 million, so less than half the cost. The new rating, bridge rating is a Deck 9, Super 9, Substructure 8. We did some substructure repairs as well. And then just kind of some important details to remember. You know, I don't know if supply chain issues are as bad as they were a few years ago, but if you're going to be tackling a project like this with your bridge maintenance agency forces, just keep in mind to kind of get in contact with your manufacturers and suppliers as soon as possible. If we hadn't done that, we would have been delayed severely, or we would have been going into the winter. Even with that, we lost about 4 weeks of time due to delays getting the bearings, concrete availability. There's a big shortage of CDL drivers in New Hampshire. So at times you had to order concrete before we even started demolition on a certain phase, 2-3 weeks ahead of time. You know, trucking availability for the precaster was an issue, and crane scheduling, but so we lost about 4 weeks because of those issues. And finally, doing things in-house, you need crew buy-in. We have, I showed the two gentlemen there, they're always willing to tackle projects, whether it's small like washing and sealing, all the way up to a bridge replacement. They like doing those projects. Sometimes they give you grief at the beginning, but they'll kind of come through in the end. But crew buy-in's important from an agency standpoint. We met frequently with the crews during the design just to kind of get them involved in the process and get ideas from them and get their input. It makes them comfortable, less on the fly problem solving and thinking once you actually get out there. And that's it from me. If there's any questions.
Is there any questions for Levi? We have a couple minutes for questions. We can try to fit some more in here too. Right there.
Yeah, hi, Mohammed Khan from NHDOT. Was your substructure rating 8 when you started the project, or it changed to 8 after you did the repair work? And what kind of repair activity you did at the substructure?
It started as a 7 and it was upgraded to an 8. Our inspectors are in a different section at DOT, but I believe it was because of the top of the bridge seat reconstruction, and we did some repairs as well while we were there.
Thank you.
Yep.
When you compared to construction cost, what do you consider as costs from your side? Like, are you considering your salaries of your employees plus their overhead, your equipment costs? Are you considering all that when you make the comparison? Yeah,
it's a good question. We do a really good job tracking our our bureau costs from a crew standpoint. We do track. It covers all time, all benefits, all overtime, our equipment costs. They put in their mileage and hours for the equipment, so it covers all of those costs, all the materials. Anything that gets charged to that particular project number will be captured in our construction costs.
Okay, with that, we will hold questions for Levi. Thank you, Levi. I appreciate that. Round of applause.